Well, good afternoon, everybody. I see participants are able to log in. I've got a couple of minutes before 1 o'clock, so we'll let people get in. So, Teresa, do you think we're recording now? I've got a record button, but it's not active. Okay, I got a thumbs up from Ms. Schaefer here that we're rocking and rolling. Let's give it a couple more minutes. Good afternoon, everybody. It's not quite 1 o'clock. I see people are getting logged in, so we'll give it a minute, maybe even give it to 1 minute after, because I can see the numbers increasing. And just to let you know, I'm saying random words so that you know that we're connected. So again, welcome everybody, and we'll get started in a couple minutes. Oh, good afternoon, everybody. I've got exactly one, but I see the number of participants still going up, so we'll give it, 1 minute so that we get everybody. Oh yeah, see the numbers going up. That's great. Welcome. Good afternoon, everybody. It's 1 o'clock, but I'm going to give it at least another minute, maybe 90 seconds or so to let people get joined in. Well, good afternoon, everybody. My name is Dr. John Barkume, and I'm the Director of Engagement at the Naval Surface Warfare Center, Carderock Division, here in West Bethesda, Maryland, just outside the Beltway. Welcome to the third of the Naval X Tech Bridge National Capital and Southern Maryland University Research Lecture Series. Our speaker today is Dr. Paul Anderson from the U.S. Naval Research Lab. That's right here in Washington, D.C., not very far from us here in Bethesda, Maryland. Dr. Adamson is going to speak today on TurboPi internship, a Python bootcamp and incubator. But before I introduce Dr. Addison, I'd like to tell you a little bit about the Naval X Tech Bridge, which means I have to figure out how to share my screen. I think I'm sharing my screen. Ashley's going to let me know in the chat if I'm doing it well here.
Yes, I can see. And if you can minimize the tab or go full screen, that'd be great.
I'm doing that right now. You can tell my great technical skills on this.
Amazing.
As I said, repeating my words, Dr. Adamson from NRL, Naval Research Lab, talking on this Python bootcamp and incubator. And I used a lot of our Navy buzzwords, but the simple thing, what TechBridge is a initiative by the Assistant Secretary of the Navy to connect together all of the diverse Navy laboratories, of which there's quite a few. And unless you're immersed in the system, you really don't understand them yourself. And here's a map across the nation with circled the capital in Southern Maryland area. And what this is a very informal coordination so that the Navy researchers, laboratories, the war fighters, the soldiers, the sailors, the Marines in the field, and universities and companies can all talk with each other, collaborate, work on problems together, and generally move some of the really challenging issues that the Navy has forward. So, it's focused on guys like you who are listening today, small businesses, nonprofits, some of the things that are, sometimes get left out in the larger programs that the Navy and DoD do. So this one is sponsored by us here in the capital and Southern Maryland region. But we are strongly linked with the other ones across the country, and we all have different technical expertises. So this is generally a good thing. More on the Capital TechBridge, and these slides are going to be made available, so that's one reason I put them up. So the Capital TechBridge is run by Dr. Krista Lossing, who also happens to be from my laboratory, NSWC Carderock. And the partners there are us, Carderock, part of the NAVC laboratory system, NSWC Indian Head in Indian Head, Maryland, also part of NAVC, NSWC Dahlgren, down the river, Potomac River, the Naval Research Lab, obviously, and the Marine Corps Warfighting Lab in Quantico. The Southern Maryland TechBridge is led by the Naval Air Warfare Center, Aircraft Division in Patuxent River. So again, right here in Southern Maryland. And the lead for that Southern Maryland TechBridge is Mr. Rick Tarr, and that's on these slides here. A quick Google of any of these terms will take you right to the NavalX website and right to these TechBridges. So, but enough from me. I now want to turn it over to Dr. Adamson. What I know will be a really engaging and informative seminar on Python Bootcamp and Incubator.
All right, great, thanks. So again, my name's Paul Adamson. I'm a research physicist at the Naval Research Laboratory in DC. What I'm going to talk about today, I'm humbly representing some really great work by many mentors at the NRL and also our partners at Syntec Technologies. Specifically, I definitely want to acknowledge Steve Richardson. He's basically my partner in crime in this internship, and very excited, very glad to be able to work with him and others at NRL to be able to execute this. But just to jump in, why am I here talking about an internship? Of all things. But I think it'll kind of become clear as I go through this talk. What we're really trying to do with this is bring in young people, get them excited about developing science codes in a continuous integration environment. And then also partner with other folks at the NRL and within DoD to kind of scale this thing larger. And so that's why I'm here to talk. And hopefully by the end of this, you'll see what I'm talking about. So back in April 2020, just like everybody else, we kind of came to the realization that there wasn't going to be a lot of on-site work over the summer at the lab, and definitely not much intern work at the lab on site. So, but we really enjoy having our interns around and working with us over the summer and throughout the year. It energizes us. It's a great recruitment tool. We look at it as, us doing our intern program is really kind of a service to the nation and the surrounding community. And now going virtual, it's across the nation. Our sponsors, the folks who give us money at NRL to do cool research, are very supportive of our intern program. And we find that it's having the interns around, they're a source of fresh ideas and perspectives. And as kind of a bonus, we get great work from them. So we definitely wanted to figure out a way to continue doing our intern program over the summer. So we came up with this idea to have a 100% remote mostly asynchronous intern program. And we were very fortunate in that Steve Richardson was the lead developer on TurboPy, had just finished up developing the core part of this framework that I'm going to talk about on the next slide. However, it was missing documentation and testing. Any of those out there that are familiar with developing code, you know that unit testing is very important, in addition, documentation. If it's not documented and it's not tested in a code, then you can just assume that it's either broken or doesn't exist. So we wanted to get some documentation and testing into TurboPy. And we thought, well, let's create a TurboPy internship and let's turn our interns loose to develop that documentation and testing. So the other goal of this intern program that we did over the summer was we wanted to expose our interns to end-to-end software development, and specifically end-to-end software development for scientific computing. You know, you'll hear a lot about continuous integration, continuous development, agile software development, that kind of thing. Well, we in Code 6770 at NRL have kind of developed our own brand or approach to continuous integration. And we wanted to expose our interns to that approach. So we had 6 high school interns, 3 staff members, and 1 student mentor. And then we had the rest of the mentors at NRL participating in this intern program. So a little bit about TurboPy. So TurboPy, like I mentioned before, it's a code written in Python. Steve is the primary developer on that, but we're all chipping in and contributing. But the basic idea of TurboPy is it gives you a basic framework to develop a physics simulation. So when you look at physics simulations for scientific computing, you typically need a few things. You need a grid, you need a clock, you need some type of model to put into the physics code. And that model is implemented in functions and classes and all the different types of things you do when you're doing programming. And you also need some diagnostics to look at, get values out of your simulation and say, okay, this is what's happening in my simulation. So TurboPy is meant to be this very lightweight Python-based framework for developing computational physics codes. And so it's modeled after a code that's written in C++, also at NRL, called TurboWave. So there's like a natural progression from developing, you know, within Python to C++, going from TurboPy to TurboWave, or other codes that DoD might be interested in. So what were some successes from last summer? Well, I've put on the screen here just a few of those. If you look at the TurboPy code on GitHub, you'll see, and you go back and look at the commit history over that time period of last summer, you'll see that the interns did 42 what are called commits via Git into that GitHub repo. They added over 2,000 lines of code. And what I'm really most impressed about is not the lines of code they added, but the ones they took out. You'll see the 381 lines of code taken out. That means that's code that didn't need to be there. There's some saying in software development that, you know, the most error-free code is the code that's not there, right? So very proud that they were able to find that code and strip it out of TurboPy, so to make that code even better at the end. So we went from virtually no testing at the beginning of the summer to almost full code coverage. So by the end of the summer, the interns working with mentors had implemented a whole suite of testing for the TurboPy app code. And so we got to almost 100% test coverage, full documentation. And we also implemented what's called continuous integration. So what that means is now anytime a researcher is working on TurboPy, they're developing code on their desktop, they make a commit to the GitHub repo, there's some automatic processes that happen in the background to run the test suite, create updated documentation, and update the world basically on the status of TurboPy. So that's pretty cool. Continuous integration implemented for TurboPy over the summer. They also developed 2 apps for TurboPy, one for a particle and field simulation, and one for just a simple block on spring type simulation that's common in physics. So these are out there now in the wild on GitHub as example apps that, you know, you can develop in TurboPy. So now any researcher that comes along and wants to learn how to use TurboPy has example apps that they can look at to get started. So the other cool thing about our intern program is it's somewhat continuous. I'm going to talk a lot about what we do over the summer, but there's a lot of things that the interns are involved in outside of the summer for those that choose to stick around and work part-time. And we had many interns from last summer. They were so excited about the work that they were doing that they decided, hey, I want to stay on, work part-time whenever I have time during finishing up my senior year in high school or whatever. So we developed this process where they can bid, sorry about that, they can bid on issues within GitHub and then basically get paid to do some additional work on the side while they're still in school. So that was also another cool thing about this process, that we developed this bidding process for folks to work on cool problems outside of the summer. So it's called the TurboPie internship, but as of this summer, it's going to expand outside of TurboPie. We're going to still keep the name TurboPie because it's kind of our brand. It's catchy. People have become to recognize it. But the Office of Naval Research is funding us to expand the boot camp and the app incubator to areas outside of plasma physics and even physics simulations. Our strongest collaborator so far is code 6900 in the biology area within NRL, but we're looking forward to bringing in other folks within our NRL and elsewhere to kind of try to scale this approach to include interns and mentors from various areas. So ideally, anyone within DoD and perhaps even the public could participate in the boot camp. We'll see. We're still working out the logistics of how we're going to execute that. But for sure, anyone within DoD can participate and follow along in the boot camp. And when I say DoD, I mean our DoD contractor partners, other government agencies can definitely get involved and participate. So I'm within NRL code 6770, pulse power physics branch within plasma physics division. We're still going to have several projects within TurboPie, the framework, but we definitely want to open it up to other code bases. So these apps that are going to be developed will be developed within other things besides TurboPie. And I mentioned a couple of the codes that are there at NRL as open source that you can go on GitHub and download today. NEPSI is one that's done within our branch, and I also mentioned Turbo Wave earlier. So we're still working out the details of the app incubator piece. We have a really good handle on how we run the boot camp because we did a lot of that last summer. We're still working out some of the details of how we transition the interns to doing this app incubator approach to the summer. And one of the reasons I'm here to talk today is I'd really like to see if there's any ideas from other people in the DoD community or elsewhere about doing software development and how to, work on small projects with interns or other staff members at the laboratories to do this app development. So a little bit about the approach to the TurboPie intern program. And you'll see a notional schedule and a little more kind of visual on the next slide. A lot of words here, but let me go through it. Like I mentioned before, the intern program, it runs continuously throughout the year. We have what we're going to do over the summer. What we're going to do over the summer is a boot camp and an app incubator. We plan to have what we call a soft start and stop during the summer because some interns show up, a little earlier in June, some show up a little later in June, and then others leave, early in August, and some stick around till late August. So we'll kind of have a slow start or soft start and stop, but we'll have a core number of weeks in the summer that we run the boot camp and the incubator. Some students are going to work part-time outside the summer, like I already mentioned. So there's going to be a lot of asynchronous work, but we will have some scheduled seminars and office hours where we'll have, contact between mentors and interns. And then also we're going to have people from outside of NRL give seminars on different missions and things like that. So that's going to be pretty exciting. And as I'll show in the next slide, we have two overlapping phases. We have this boot camp phase and the app incubator phase. So during the boot camp, the students and interns are going to learn about Git, Python, unit testing, integration testing, how to do good documentation, and then how to implement that continuous integration approach that I mentioned on the previous slide. And then in the app incubators phase is where we transitioned to where mentors are going to work one-on-one or one-on-two or so with interns to develop different apps, either physics apps or bio or whatever area it is that is of interest to the mentors. And this could include modeling and simulation, data analysis, different things like that. We'll probably be doing a lot of it in open source codes that are on GitHub, but we might also do some of it in private GitHub repos behind some type of firewall. We use realpython.com a lot for training, but we also tap into other resources. And if you go and look at the TurboPy training public repo on GitHub, you'll see the link there at the bottom right-hand corner of the screen. You can kind of see there how we ran the internship last summer and the links to all the realpython.com training and other resources that we used. So I mentioned GitHub a lot in asynchronous communications. One of the keys to this is we're really trying to immerse the interns into a true software development environment in a software engineering team. So there's a lot of asynchronous communication going on via GitHub issues and other things, what are called pull requests, where interns submit code that they want merged into the code base. And there's nice dialogue that happens within those issues and pull requests on GitHub. Things that, you can't really do necessarily in a 30-minute phone call. It's really deep technical discussions back and forth in an asynchronous mode. We're going to use Microsoft Teams for seminars and office hours and pop-up meetings. And one key thing about the intern program is that we really are trying to push that the interns have ownership of it. So what we did last year was we implemented what's called an intern admin and project manager roles. We're expanding it this summer to having what we call an operations officer role, that person's going to be in charge of the schedule and doing the logistics, coordinating with seminar speakers and all that. So we really the goal is to have the interns run and manage a lot of the intern program so that as it scales, we're able to bring in more mentors and more interns without it collapsing under its own weight, so to speak. So that's kind of the idea. And I have this, a box at the bottom that really just trying to reinforce that the whole purpose of this approach is to really integrate, ingrain into the interns this concept of continuous integration via GitHub issues and comments, cloning the code, branching, creating tests, writing code, retesting your code, and then once you're good with it, submitting it as a pull request. But then it's not over, because then somebody that has control over that repo goes through a commenting period and then finally merges the code into the code base. So really, I just want to emphasize that we're really trying to instill that how useful the continuous integration approach is. So here's the draft schedule, just to kind of give you an idea for what we're going to be doing this summer. Again, I mentioned we have the bootcamp and app incubator phases, and you can kind of see graphically where, the bootcamp is early in the summer, and then we phase into an app incubator part of the summer, where we then transition to interns developing codes for physics, bio, whatever application. So we'll have a kickoff sometime in mid-June. We'll dive right into learning Git and GitHub, basic Python, object-oriented programming in Python, unit testing, documentation. For those interns that are returning from last summer or already have some kind of background in Python, we'll jump into some advanced techniques, some advanced topics like design patterns, advanced object-oriented programming, developing and publishing Python packages, and all that. So by the midsummer, students are going to have a good solid underpinning so that they can transition to developing those apps. And then at the end, we'll wrap up with presentations by the interns. So 2020 didn't go perfectly, but that's good. We like a messy program. We like friction. We like things to be a little complicated. We don't like things to go smooth, because if it's going smooth, that means you're not really pushing boundaries. You're not really trying to make things better. So we did learn some lessons from last summer. One thing we did, we kind of fumbled when it came to transitioning from the bootcamp phase to the actual app development. There's realpython.com to learn Python, but there's no realphysics.com. So how do you transition to where the students are learning how to do Python to actually implementing code and some type of model, a physics model or whatever type of model? So the way we're going to try to tackle that this summer is we're going to hand all the interns a more thought out description of the project that we have in mind. We're going to challenge the mentors to really think about what technologies need to be brought to bear to solve that problem, to do that app development, so that the interns have a good idea of, okay, what it is that they need to grasp during the boot camp phase so that they can transition to that app development phase. So that's going to be important, we think, and we'll see how that goes. We also didn't, this is kind of a tactical level thing, but we didn't define a default development environment for coding in Python. We're going to do that this year. We think we've got a pretty good tech stack in place. We're going to roll that out, provide interns with laptops with those that are already installed so they're ready to go. And then some good things we learned. The intern admin and project manager roles that I mentioned before, we're going to expand that. We really are going to give the interns leadership and management over this intern program. So it's going to become a largely intern managed and led effort over the summer. And then we found that it was really good to have these basic projects for students to work on, be it documentation or writing tests for existing codes. We found that gave the interns something to work on before they become very proficient in coding in Python, so that they could kind of get their feet wet, dip a toe in the coding paradigm, so to speak. And then once they get more proficient, then they can move on to more complicated things. So we're going to definitely identify several types of projects that are just focused around documentation and testing. So that's pretty much all I have. I really wanted to leave time for folks to ask questions in the Q&A, and we can kind of maybe have a dialogue as best we can in this webinar environment. But I do want to say, if this is interesting to you, if you find that maybe your organization, be it contractor, academia, or DoD government agency, if this is of interest and you want to learn more or maybe collaborate in some way, just please email me. We'll try to get my email address in the Q&A. Also, in things I'm looking for are app project write-ups. If you have a seminar topic that you think you would like to give, maybe you're really good at some aspect of coding, specifically Python, continuous integration, unit testing, whatever. Maybe you would like to be a guest speaker at one of the seminars. What does your organization, what approach to code development do you use? Maybe it's not the one that we use, but we'd like to expose the interns to all those different ideas. And I mentioned mission briefs. Those would be cool if there's anybody out there that would want to give a mission brief to the interns. And then if you're interested in participating at some level, whether it's leveraging the boot camp or the incubator phase, let's discuss and see if there's opportunities. So that's all I have. And just, I'd love to hear from anybody if they've got any other ideas for collaboration on this.
Any questions? It looks like the Q&A. Okay. I actually now see one. There's only one question. I have lots of questions myself, but I'll start with who's in the Q&A. Are the applications still available for TurboPy this summer?
So we have a few slots left, and so we are ramping this up. So this year is kind of this. We'll call it our ramp up, our first ramp up year. So we're not going to be able to add very many interns this summer, but we do have slots available. And again, if anybody's interested, let me go ahead and just type my email address here.
I just added it to the chat.
Interested. What's that?
I just put it in the chat.
Oh, okay, great.
If you can get it in the Q&A, I couldn't seem to get it in there, but.
Okay, let me put it in the Q&A here. All right, I put it there, but I don't know who all can see that. Hopefully folks can. If not, we'll figure out a way to get you my email address. But yeah, the answer is yes, there are some slots. We don't have a formal process for bringing in applications and reviewing them just yet, because again, we're ramping this up. But we do want to hear from folks that are interested in participating, and we'll see what we can do.
Sounds like emailing you is the answer.
Right. Yeah, definitely email.
Another question. Can Can you give an example of one physics topic that was performed? Sounds like somebody wants to really dive in and see an example of a topic.
Yeah, sure. Let me just go ahead and just a sec. Let me go ahead and go to one real quick. And I'll go ahead and share that.
There's another question here. Can you give an example of one physics topic that was performed, like a flavor of what was accomplished?
I think that's what we're trying to get that one, Ashley, right now. Oh, here we go.
Yeah, so here's, if folks want to go check out TurboPy on the web, if you go to turbopy.readthedocs.io, this is where the documentation for TurboPy exists. If you see on here, you can find a link to an example app that I mentioned earlier of something that the interns coded up. This is the particle and field. Basically, it's just a simple charged particle motion simulation. So essentially, they used the TurboPy framework to code this up to simulate the movement of a charged particle in a field, an oscillating EM field. So this is kind of one example of an app that was done. We currently have in the works a publication on a what's called rigid beam model for a intense electron beam driven plasma. So that's going to be coming out. That simulation is a little more difficult than just an intern project. That's it's the culmination of about a little over a year of work by multiple researchers at NRL, but that's going to be coming out soon. And that's all done in TurboPy also.
We've got sufficient time, and we didn't want to just talk in one direction all the time. So it says here that you should mention that someone must have known about this. The 2020 interns are now published authors.
Right, I should have mentioned that. Great, I'm pretty sure that's Joe Schumer or Steve Richardson probably prompted that comment.
Mr. Anonymous here, yes.
Yeah. So, yeah, what the cool thing was, so TurboPy, it's not only on GitHub, but there's an actual peer-reviewed paper that was published describing the TurboPy framework, and all of our summer 2020 interns were co-authors on that paper. So that was pretty cool. And I see the other question is, what prior programming, other content knowledge are interns expected to know prior to the program? Well, so this is the cool part about this is that's why we're doing a boot camp, and we call it a boot camp. Is we expect people to come in with zero knowledge, and we will get them from zero to programming in Python in just a few weeks.
Now that there's no open questions, and being one of the organizers, I'll monopolize the conversation and ask my own question and make an observation. One is, and I think all the professors and teachers who I know, I see a few out there, recognize it's pretty easy in this. I mean, you can go and get on various ones of these Python, $15 courses and good stuff, and I'm nothing against those, but getting something where you can get a real physics answer and get that interplay between doing something of value while you're learning the programming is rare. It's really hard to get for the students and people, and it can be done early. You don't have to, have 2 years of doing internet solo programming to get there. So I think that's very much the right attitude. I will also, again, that I'm monopolizing, I see some of my colleagues from some of the other NAVSEA laboratories, and that you know who I'm talking about, and myself. I have at least one person, senior technologist, means one of our senior top scientists in areas of ship survivability, who is really one of the leads in modeling. And he has some very good thoughts on what goes into the interaction of physics and a model, and it's not just coding, and what's needed. And I think he has a paper he gave on that topic that's very high level, and you can see me twisting his arm already. Dr. John Sturgio, see if I can get him sometime in the summer to talk to you guys.
Yeah, that would be great. We really are interested in that interface between programming and solving physics or solving real world problems. And how do you make that transition? And then also, how do you do it in, in a good way with respect to software engineering, continuous integration, unit testing, integration testing, all that stuff. So we are really interested in that part of the problem. And honestly, a big part of my motivation for helping to start this bootcamp and app incubator is trying to tackle that problem exactly. It's like in some ways, our interns are kind of like our unsuspecting, guinea pigs for developing those approaches to doing software engineering for scientific code. So that's another just side benefit of this program is developing those approaches through intern engagement. So I see the question is the bootcamp only available in the summer or during fall and spring? Right now, the bootcamp is only during the summer. If we could have the resources to do it other times of the year, I think we would be supportive of that. And we'd have to figure out, is there a demand for that? Would there be people that would want to participate during times outside the summer? The first thought that comes to my mind is that we could have the student, the boot camp in the summer could be focused on students, and the boot camp during the off season, so to speak, could be focused for staff members at the Navy organizations or DoD organizations. So maybe that's something to think about. I think I should comment that, what we have in mind, this bootcamp and incubator applies to everyone from high school age, undergrad, grad students, staff members, professionals. We think it's valuable for anybody. We think our goal is for this to scale to help out everyone that's doing Python in any lab or other organization. In fact, we have for sure at least one NRL staff member that's going to participate in the boot camp.
Did you see, I don't know if you can see, is there a list of requirements for the application?
No, so far when we've been considering intern candidates, we've just been looking at a resume and transcript. So no particular requirement as of yet. Like I say, we started out last summer. This was kind of think of it as a pickup game. This summer we were funded to expand, and this is our first scale up year. We haven't formalized a lot of things. And then I expect as we go forward, we'll formalize some of those things a little more.
And also I see two questions, deadline for the application and non-US citizens, permanent residents.
So we haven't set a deadline. I would say if you're going to participate in the boot camp, starting mid-June, we're getting close to the time period where we need to, firm that up and get folks on board. But we haven't set a deadline yet. And like I mentioned before, this intern program overall is continuous. It's ongoing. We have a continuing intern program. The boot camp phase in the summer is just between mid-June and mid-late August.
I just see one other comment at the moment, and I'm guessing it says anonymous attendee, but I can make a guess as to who it comes from. The Naval Air Warfare Center, Aircraft Division. Now, if you recall, that's another part of our Tech Bridge family here in the capital Southern Maryland regions. Runs a 2-week computer coding camp for middle school students. So that's entirely what I would call a STEM outreach, if I understand that program. And it would be great to get someone in the Turbo Pi program to connect with the beginning coders. Now, I'll interject. I know you got to, being a co-Navy employee, and everyone here, university, recognizes balancing your time, the value you can add, and what you can do and use for the students. Instead of taking your time, take one of your hotshot leaders or system and have them talk to the middle school students. Give them some support to do that. And that would be a way to connect through that is probably more meaningful than coming from the august verified high-level research scientist at the Naval Research Lab. Have it come from directly from the high school student. So
Oh, yeah. I
if
think
you see
that's-
that comment, that's a great follow-up.
Yeah, I think that's a great idea. I really like that way of thinking.
Um, we're just letting people absorb this. I know, we can't really do an open microphone, which is always a shame with these. I like the personal interaction. Feel free to type another question in, or we'll start to wind this up a little bit. While, in case someone's still thinking, let me do some housekeeping here. So we will send, you noticed everyone here had to register. And what we do with that is I get your email address so I can notify you of future events here. I'll mail you a PDF of Dr. Adamson's talk, so you can have that, and that'll give you the references to the sites that he had on the GitHub sites and everything. There should be a recording of this. Now, the recording is up on the NavalX YouTube channel. So instead of waiting for my email, which I'll get around to when I think of it and juggling things, you can actually subscribe to the NavalX YouTube channel, and then and being YouTube, if you see something interesting, watch it for a few minutes. So I would highly encourage you to do that. Just subscribe to the NavalX YouTube channel, and you'll get a full recording of this event on there. Are there any other questions? I don't see any at the,
Yeah, that's a really good question about, is it possible to run the bootcamp self-paced anytime in the year? If someone wanted to, they could go to I mentioned the TurboPy training public repo that's on GitHub. Anyone can look at that and go through that themselves. And that it's a good idea that perhaps we should consider just setting up a TurboPy training repo on GitHub that is just left open, and folks can go through it and make commits to the repo, and then we could, folks at NRL or elsewhere researchers and scientists could look at those and give feedback. So that's an interesting concept. But right now, anyone could look at the TurboPy Training public repo and go through that and see what we did last summer and just and do that.
As we wind down here, I think I want to mention something here that I suspect people are thinking about. Again, I took a sneak peek at who's online here, and it should be obvious that this is a bootstrapped up enthusiastic idea from the scientists at the Naval Research Lab, and they're limited in the number of mentors to be able to do this. And this program might grow into something else sponsored, but you should always, if you're high school student listening to this, college student, or in a university, go to the Office of Naval Research website, look at the intern opportunities. There's the Naval Research Enterprise Intern Program, the high school science and engineering apprenticeship program. My daughter's in that this year, which is why these words flow off my lips pretty well. We are not in that cycle. Those guys and girls are starting up very shortly, but that cycle will be in the fall, and we'll probably do another NavalX event like this solely to advertise those programs right at the time for them. And so that gets you into an official program that's all 10 of the NAVC labs, all of the NAVAIR, other labs, Naval Research Lab, in a larger, more official program. And so, if you're thinking of those things, start researching them now. These things, the ONR, Office of Naval Research main site, the NRL site is a great way to start, because I know those are up there. And I believe our lecture that we gave last fall here on NavalX is on the YouTube channel. And so any other, if there's mentors from the Navy labs who are interested in this, I think personally this model could be translated off to one of our other sister labs without any trouble at all. Please contact Paul, or you can contact me. And with that, I see no other questions. We've been just about exactly 45 minutes. I'm going to draw this to a close. So thank you, Dr. Anderson. Thank you again, Ashley.
Thank you. I
Start.
really appreciate the opportunity.
Thanks,
All right,
everybody.
thank you guys, and hope you guys have a great rest of your day and a wonderful pathway into the weekend.
Bye, everybody.